assuming that, the vision system works, the robot arm works, and the gripper works properly, um, what would, say, a client expect to have, right? If we're talking about human beings, human sorters not being very effective, maybe even being a little bit slow, or if there's a labor shortage, would it be fair to say that there would be some like 50% gains in efficiency or in speed? I assume it would also depend on the specific application, but what could somebody expect? What could a sorting center expect in kind of efficiency and speed gains?
Yeah, well, the first thing they can expect is availability. So
Mm,
the robot is there every day. So
yeah.
that's the first thing. That's a cool thing. It's underlooked. It's hard to price. It's hard to put into your calculation of payback, but you actually have predictability on your capacity to produce, which you don't sometimes nowadays is more and more difficult with
Yeah.
people.
Yeah.
Um, so that's important. The other thing you see is constantness in two things, in speed. So the speed will remain. So we typically is the robot will be 30-40% faster than a human
Okay.
over the whole day.
Hmm.
So for many years we had to argue that with our clients. They were like, yeah, well, I'm not sure it's really achieving as good as my best sorter, but the best sorter gets tired, and the best sorter, when we measure them, they're really good, but when you're not there, they're relaxing like anybody would. So
Right.
um, the robot delivers maybe 30, 40, 50% efficiency, 100% efficiency on speed. So and but they're constant, and that's the cool
Yeah.
thing about
Yeah.
it. And and then there's the precision. Depending on which type of sensor you're investing in, you could see up to 10-15% increase in overall quality of the product. So but that metric is a bit pernicious. It's not that easy to measure, but overall you gain quite a bit of efficiency depending on how you sort. You're doing positive sorting, you're doing negative sorting. When we do positive sorting, we say we capture number two plastics. Then we can be super precise. We can go
Hmm.
up to
Hmm.
98% precision on this, because every time we grab something, we know what it is.
Yeah.
When you do negative sorting, we're actually trying to clean up a bunch of plastic, trying to remove what is not the desirable product. Um, you can achieve great things, but sometimes there's some stuff that you just don't recognize or you don't see. There's a lot. It's kind of there's a whole randomness in QC. Uh, Out of a bunch of plastic bottles, sometimes you remove a piece of wood, sometimes you remove a piece of paper, sometimes you remove. So there's so many different type of products that could be commingled with the product.
Hmm.
It makes QC a little bit more difficult to achieve overall. But the expectation, and finally, it's the ability to run 24/7 without.
Yeah. Yeah.
And that's the most right now. That's the most challenging part of bringing automation into the waste industry. Most of the waste industry runs on, well, there are a few guys runs 24/7, but most of them run on one or two shifts. So they have design system that run super fast for 8 hours or 16 hours a day, and then they stop.
Hmm.
Now, if you put robots on these lines and you keep running it like this, it's the same as paying people to sleep, because these
Right.
robots will actually sleep at night and you pay them nevertheless. So the big challenge is for the new centers and some of the existing one to adapt, is to try to run maybe slower but longer days, and to get better precision, overall increase in productivity throughout your day, and not having and predictability in your production, because you have availability of robots and you know what they can do and what they cannot do. And so overall you gain high efficiency. But when you bring robots into a waste sorting application, if you think you're gonna idle them for 8-10 hours a day, that's probably not a good idea.
Right, right. Yeah, so I would assume that there would be some sort of, business shift or even some cultural shift within that organization itself to change the way that they're working, from that, 1 to 2 shifts to 24/7, right?
Yeah.
Because even the best pickers, you were saying, get sick and has holidays, etc. Whereas a robot, so far, they don't need that.
Yeah. The end game of automating in the recycling world is to design a completely autonomous recycling center. So
Mm,
there's a door there, the truck dumps in, and everything is automated. Because if you interlock if the right now the problem is also there's the interlock between the humans and the robots. So our clients will come to us and then go like, I got 5 guys there, I'd like to replace. It's difficult, I can't find them. So we'll put robots there. But if these robots are dependent on somebody else on the line, that means these robots will stop for lunch and they will stop for breaks and they will actually sleep at night
mm,
because they are interlocked in that overall chain of supply. They are
right.
interlocked with other humans. So they're not at their greatest if that's the case. Now, if you go into a completely autonomous center where you actually where you don't have any human interlock within the process, then you dump the material into this large bunker that feeds a belt that is driven by the robots. And by the way, the robots, because we see everything, we can actually regulate the pace at which we can feed the material
Ah,
in.
right,
So,
right.
for example, if I have if I'm picking just plastic bottles, for example,
Hmm.
and and there's a lot of bottles coming in, like a bunch of bottles coming in, I can slow down the system and make all the picks, and then restart the system. If there's nothing on the belt, actually can speed it up way faster than what you would do normally. Typically now we run recycling centers at steady speed, and if we miss stuff, we miss stuff. If there's too much stuff coming
Mm,
in one go, they rarely are regulating this sort of variable speed. But with robots, we can do this. So, and it's all programmable. So if the client says, well, my goal is to make quality, I'm ready to slow down, then you set it up on quality and everything will go slower, but we'll do all the work properly.
mhm.
And if he's in a pickle because there's a lot of material coming in, and he's like, I gotta get rid of all this stuff, he could put himself on high speed, lower quality setting, and we'll pick whatever we can. And actually, that's
Right.
what happens in real life today. Recycling centers are run like this. I mean, like usually they're not so much into variable speed, but they're more into fixed speed, and they catch what they can.
Right, right.